Hi everyone, welcome to JEE MAX. This is Umasankar. Welcome to JEE Main's Advanced Extreme series. This is season number 2. Successfully we have completed season number 1. And in season number 2, we are completely concentrating on the topics. And complex numbers is one of the most important topic and it has its own importance in all competitive examinations including JEE Mains and Advanced examination. And so far we have completed lesson number 4 in complex number. This is lesson number 5. And again I am requesting please don't forget to check the description. There I am providing very good information for you. And through that description I am providing the links for downloading the new pattern of JEE Main and Advanced question papers and assignments. And they are very useful for you. Now, in this lesson number 5, we are concentrating on square root of the complex number, cube roots of unity, and fourth roots of unity. Okay, my friends, what is square root of a complex number? You have to first by heart these two formulas and practice this well, because you will save the time with help of this particular formula, because they're very easy. Almost they are appearing like the square root of this third. If you have got a plus ib, square root of a plus ib, then the similar approach is for square root of a minus ib. The only difference is for square root of a plus ib, since here for plus is there, the plus sign appears here, and just replace plus with minus, then you will get the formula for square root of a minus ib. But the question is how to get square root of a plus ib. This I will explain. Now see this proof. First you take square root of a plus ib is equal to plus or minus x plus iy. Because for real numbers one can say that square root of 4 is equal to 2 only, not plus or minus 2. Whereas in complex numbers it is not possible. That's why square root of a plus ib we are considering that as plus or minus x plus iy. So what to do? Squaring on both sides. After squaring on both sides, a plus ib equal to that is x square minus y square plus 2ixy, because I square is equal to minus 1. Now equate real and imaginary parts. So my real part is x square minus y square is equal to a. You call this as equation number 1. And my 2xy equal to my b. This is equation number 2. Now what I am doing is find x square plus y square. For that, here I am writing one important concept. These are the techniques only you have to practice, because all these things that I am writing on paper, they are just what manipulation techniques. So this is x square minus y square whole square plus 4x square y square. So this is nothing but a square plus b square. So what is my x square plus y square? That is under root a square plus b square only. You call this as equation number 3. Now in your hand you have 3 equations. One is x square minus y square, another is 2xy, another is x square plus y square. Now what I am doing is now add 1 and 3. So you will get 2x square equal to root of a square plus b square plus a. Therefore my x becomes root of root a square plus b square plus a by 2. Similarly, subtract 1 and 3. You will get y equal to root of root a square plus b square minus a by 2. Now you substitute these values in place of x and y, you will get the answer for square root of a plus ib. The similar approach we may use for finding the square root of a minus ib also. So it is very simple proof. The only thing is, though it is in complex numbers, but entire thing is I have applied all algebraic manipulations only. So you practice these formulae because it will save your time for solving some other mixed oriented problems. That problems and that kind of oriented questions we will see in our next videos. Now again I am giving all the steps very neatly. See, squaring on both sides and equate real and imaginary parts. And as I said earlier, find x square plus y square whole square, thereby you will get x square plus y square. Now in your hand there are three equations. Now add 1 and 3 and subtract 1 and 3, you will get x and y. Therefore, root of a plus ib equal to plus or minus root of root a square plus b square plus a by 2 by plus I into root of a square root a square plus b square minus a by 2. Similar way, we can prove the proof of square root of a minus ib also, that is left to you. You practice that on paper. Now, with help of these two results, we are now finding some of the deductions, and please practice all these things. Of that, first one is square root of a plus ib plus square root of a minus ib. Here, you will get this as the answer. Similarly, after subtraction, you will get this as the answer. Practice these two results also, because sometimes it may save your time, as I said. But what is square root of I? This I can write it as square root of 0 plus 1 into I. So as per formula, square root of plus or minus, later I will write. Don't worry about plus or minus and all. First initially, okay, let it be plus or minus square root of a square plus b square, 0 plus 1 plus a, that is 0 by 2. Since it is plus I into square root of a square plus b square minus a by 2. After simplification, you will get this as plus or minus. This is root 1 means 1. It is I. 1 plus I by 2. This is for what? Square root of root I. On the similar way, you can find the square root of minus I. And these are the very, very important results. In time, suppose in some problem, you may utilize these are the shortcuts also. These formulae as shortcuts. So in that aspect, you have to practice these two formulae in a proper way. And moreover, now we are concentrating the most important part of complex numbers, which is cube roots of unity. Cube root of unity is this, I can write it as cube root of 1. I don't know what is cube root of unity, how many cube roots of unity will appear, I have no idea. So let us see the proof first. Let it be x. Now what I am doing is cubing on both sides. So x cube is equal to 1. You bring that 1 this side, x cube minus 1 equal to 0. Factorize this, x minus 1 into x square plus ax plus 1 equal to 0, you will get it. Now two factors are there. One is x minus 1 equal to 0. Another one is x square plus x plus 1 equal to 0. This after simplification you will get x is equal to 1. This is in the form of a quadratic equation. So apply minus b square root of plus or minus square root of b square minus 4ac by 2a funda. So minus 1 plus or minus square root of b square minus 4ac by 2a. After simplification, this I can get it as plus or minus 1 plus or minus root 3i by 2. So finally, what are the cube roots of unity? I got 1 minus 1 plus I root 3 by 2. Forget about minus. And the next one is minus 1 minus I root 3 by 2. These are the cube roots of unity. In general, we consider this as omega and this as omega square. So if anybody is asking about the cube roots of unity, immediately you can say that 1 comma omega square are cube roots of unity. This symbol is denoted by omega. This is called cube root of unity. In general, omega, if anybody is asking you, then you can say that omega is minus 1 plus I root 3 by 2. Not necessary that minus 1 plus I root 3 by 2 is always omega. In general, we are considering. Otherwise, you can take omega square as minus 1 plus I root 3 by 2, something like that. As long as they have not given any other notations, but you just confine to 1 omega omega square or cube roots of unity. Since these are the roots of unity, if I have substituted omega, it should satisfy the equation. That's why omega cube is equal to 1. So whenever omega is cube root of unity, automatically it should satisfy this equation. So if I have substituted this, it becomes what? Omega cube is equal to 1. Therefore, omega square is equal to 1 by omega, I can get, or omega is equal to 1 by omega square. That means omega and omega square are reciprocals to one another or inverses to one another. And moreover, since omega is cube root of unity, automatically it should satisfy the equation x square plus x plus 1 equal to 0 because it is a part of that one. So omega square plus omega plus 1 equal to 0. That means sum of all cube roots of unity is equal to 0. So with this, what we learn, sum of cube roots of unity is equal to 0. With the help of this, we can derive omega square plus omega equal to minus 1 and omega plus 1 equal to minus omega square and 1 plus omega square equal to minus omega. These are all of the convenient recommendations or deductions which are being extracted from the concept cube roots of unity. Okay, so these are all of the fundamentals one should practice with the help of cube roots of unity, and these properties may helpful for you in solving several questions which are related with cube roots of unity. Later, we can practice the geometrical interpretations of cube roots of unity in another lesson, but here just I am giving the analytical approach only. And if anybody is asking you what is the quadratic equation having roots, cube roots of unity, omega comma omega square, then immediately you can say that 1 plus x square equal to 0. Based on that, several times the problems were repeated in a competitive examination. So just to go through them. Cube roots of unity are what? 1 omega omega square, where omega is equal to minus 1 plus I root 3 by 2 and omega square equal to minus 1 minus I root 3 by 2. How to get it? Cubing on both sides, you will get two factors and equate them and solve them. You will get answer as in general 1 comma omega square. Of that, in general, we consider omega is equal to minus 1 plus I root by 2 and omega square as minus 1 minus I root 3 by 2. Now, the properties of these cube roots of unity, just I mentioned now, these are the properties. And here, fourth, fifth, sixth property, n is any integer. Omega power 3n means what? I can write omega cube whole power n, but omega cube is 1. Omega power 1 power n is equal to 1. Similarly, omega power 3n plus 1, that I can write it as omega power 3n plus 1 as what? Omega into omega cube whole power n, that is omega into 1 power n, that is equal to omega. Similarly, omega power 3n plus 2, where n is what? An integer. So, these are the concepts and most important properties of cube roots of unity. And of course, my friends, as I said, third property is very, very important, because what is the quadratic equation having omega comma omega square as roots? Immediately you can say that x square plus x plus 1 equal to 0. Not necessary that x square plus x plus 1 equal to 0. You can take y square plus y plus 1 equal to 0 or t square plus t plus 1 equal to 0. Anything, any other variable also you can represent. On the similar line, how can we find fourth roots of unity? What are the fourth roots of unity that we have to find? See, fourth roots of unity, let fourth root of 1 is equal to x by rising power 4 on both sides. So let it be x power 4 equal to 1. So you bring this side, x power 4 minus 1 equal to 0. Factorize this, x square minus 1 into x square plus 1 equal to 0. So x square minus 1 equal to 0 and x square plus 1 equal to 0. X square is equal to 1. X is equal to plus or minus 1. Here x square is equal to minus 1. X is equal to plus or minus I. So the fourth roots of unity are 1 minus 1 I minus I. So just like cube roots of unity, here fourth roots of unity are like this. If I is fourth root of unity, then I power 4 equal to 1. Similarly, minus I power 4 equal to 1. Okay, just like if omega is cube root of unity, omega cube is equal to 1. Similarly, if I is fourth root of unity, I power 4 is equal to 1. The same things here I am mentioning. And the proof is also similar to just now I have completed. Okay. Okay, see how can we get the how to extract the fourth roots of unity, because since cube root and fourth root, they are very easy for you. It is easy way we solved them, and we got these results. See the procedure. So, my friends, these are the most important points regarding the cube roots of unity and fourth roots of unity of the complex numbers. You have to practice them. I think if you like this video, please share and subscribe my channel and press the bell icon. There you will find very good notifications. And after this, we will meet with another lesson. That is lesson number 6 of the complex numbers. Thank you.